Good afternoon. Now let's begin where we have ended. We have ended at question number 2. Now we will going to discuss question number 3 in continuity. Now question number 3, a particle started from rest. Its acceleration at an instant is now acceleration it is given. Acceleration is equal to 10 upon v plus 1. Correct. V is the instantaneous velocity, the distance traveled till particle attain the velocity 15. Now we have to calculate distance when the velocity is 15. So here we can say like acceleration. If you remember, I told you xt, vt, and at. Now in the given question, we have given a. So the basic chronology like acceleration, velocity, if acceleration it is given, and we have to just go and calculate the displacement. So these are the few sequence that you better to remember. Now let's quickly see. Now we have given acceleration as a function of v. Acceleration as a function of v it is given. So what we supposed to do here, we can say if velocity as a function of v we have to calculate. Now this coding is important. Velocity as a function of x if you can establish, so you can calculate. Now here what we can do, now acceleration in terms of distance we can write, because acceleration has a two formula, dv over dt or v dv over dx. Now t it is not essential here, that's why we will apply the basic formula, that is v dv over dx. Fine. So v dv over dx, once we have applied here, we can say v dv over dx, and that is equal to 10v plus 1. Now we have to take a variable separable. We can shift the velocity term in the velocity direction and distance term with the distance direction. Now we have integrated velocity since 15 we have to calculate, and initially let's say initial displacement we have taken as 0 to 0 to x and 0 to 15. And this is all about the integration v to power 2, v3 by 3, v to power 1, v2 by 2, and placing the limit, and we can get the answer very easily. So this type of question seems to be very easy. You have to just go and recognize which expression you have to use, and accordingly you can take the variable separable and place the limit and get your answer. So let's take the question. Next question. A stone is thrown up with V naught due to the air resistance. Now this is important. Have to know what question we have done. There's no resistance. Now air resistance is there. Its retardation is, now retardation is basically a value they have given as k root v. Once again, this is a variable type of acceleration question. Find number of time to reach the highest point, max height it will going to reach. Now once again, we cannot directly use the equation of motion, but we will use the variable type of equation to solve the question. So let's quickly see. Now here we can say we have given dv over dt is equal to, now acceleration given in terms of velocity. So what I have calculated, because time we have to calculate. For time, I am keeping the expression of as dv over dt is equal to minus the k root v. Now, once again, variable separable method we are going to use here. The variable separable method v dv over dt minus k dt. Now, from there we can calculate the t. So this is the time expression we have calculated. Now, once the time calculation is got calculated, we can calculate the height. Now, height, once again, now I'm keeping the acceleration in terms of distance. Always remember once acceleration with respect to time you will calculate when you are looking for time. And whenever distance, v dv over dx. This expression we will going to use. Clear? So once we have calculated, now once again variable separable method we are going to use. By this way, you can calculate the value of h. That is a desired at the maximum height. What will be the value? So once again, this is a good problem that will give you some sense of how to approach when the acceleration is variable. Clear? So let's quickly see the next question. Now here, uniform acceleration. I already told you two type of situation is there, uniform and so when the uniform acceleration it is there, uniform acceleration, when acceleration is constant, these are the tool for us. These are the tool for us through which we can calculate so many things, and you better to remember these few, you know, direct expression, so that will speed up your calculation. When u is zero, so we can say time of flight. Time of flight means when the particle will start its journey. Fine. And second situation, the particle will drop. When the particle will drop means u is equal to zero. It will speed up. So basically, what time it will take to reach, that is called as t1. And here as well, once the initial velocity does not zero, it will reach to the highest point. Let's say this is t2. So t is equal to v upon a. Which equation we will use? V is equal to u plus at. Since u is 0, so we can say v upon a is equal to t. This is called time period, that is t1. Similarly here, once you will keep v is equal to u plus at in final velocity 0, once again we can get the same expression. Fine. Now next, we can use second equation, s is equal to ut plus half at square. If v is equal to 0, so here we can get t is equal to 2s by a. And this equation will be applicable when distance it is given. This equation is applicable when velocity given. And respectively, s is equal to v square by 2a. So this equation will give you quick results, so better to remember. Now here the stone is dropped from the top of the height h. After another stone is dropped from the balcony 20 meters below the top. Both will reach simultaneously. What is the value of h? So here we will use the simple equation of motion. Now here you can see this is the diagram that will going to give you a very good clarity. Now here it is. This is the total height to which the stone will be dropped, and the next stone it will going to be dropped from the balcony, that is 20 meters below. This is 20 meters below. And let's take the stone A. Initial velocity is 0. Final velocity we don't know. Acceleration given 10. Height is h, and time taken t. And stone B, once it will going to start, so it has started its journey from h minus 20 height, because this total height h, so it will be h minus 20. Fine. And time taken, because it is dropped after a second to the time clock, of course it will start t minus 1. T minus 1. Fine. If it has taken, let's say, 5 seconds to reach at the bottom, it will take, of course, 1 second less. Clear? That's why they will reach at the bottom simultaneously. The statement is both reach at the bottom simultaneously. So we can say stone A. If it has taken 5 seconds, let's say, so it will take, of course, 4 seconds, because it was dropped 1 second after. So we can use simple h is equal to half at square, and the next equation will be h is equal to because the initial velocity both of the stone will be zero, and time it will only change because it will drop after a second. So here once I keeping the value of h from equation 1 to equation 2, fine. And after solving, it will be t is equal to 2.5 seconds. And once the t is equal to 2.5 seconds, if you are keeping once again in the given expression, you can get the height value. So I thought question was easy. You have to just go and make this equation and systematically put the values, and you can get every parameter afterward. Now let's quickly see the next important point of motion under gravity. Now this is important. Motion under gravity is one of the key section of motion in 1D. The time of ascent and time of descent. Time of ascent means time taken to reach at the maximum point. Time of descent, time taken to move down. This is time of descent. That is u by g. Total time, of course, it will be 2 times. Now, h is equal to u square by g because final velocity is going to be 0 and time taken t is equal to 2h by g. So these are the extreme formulas that you will going to use to calculate other parameters. Now, here we can say the particle is at height h twice in its journey. Right? How the particle will be twice? Let's say this is a forward journey. If the particle is started its journey, it will move. This is the first time it will reach. Fine. And after returning, let's say it will once again move. So here we can say 2 times it will cross the any point you can say. So this is what they have written. If we consider now, if we consider this is small h, fine, and let's say this height is capital H. So capital H is greater than h. So that means small h it will be traveled by how many times? 2 times. Here you can see first time it will travel once it is moving up, and second time it will travel once it is moving down. So that's why it is written particle small h will be twice. Now after solving h is equal to ut plus half at square, there is a 2 time interval. Here you can say that is, this is important, TAB. This is TAB once it will reach to this height, and second time once it will travel all journey and reach to the next point. So here we can say TA, that is TAC. So you can say TAB this much time and TAC. Of course, TAC is greater than TAB. Fine. So regarding the same, this is a question use initial velocity g is 10. Find the time taken to hit the ground. Now time taken to hit the ground. So here we can say if it will throw on, and if we use the basic equation, so it will reach to the maximum height and once again return back and going to hit the ground. So we can say initially the particle is over here. So once we use h is equal to our reference is setting, our reference setting is important. Reference is set over here 0, comma 0. So with respect to which effectively, if you are talking the displacement, it will move up and it will move down. So overall, once we add together, so don't you feel it will cancel out each other? Let's say AB and let's say this is BC. So this AB up, BC down, same. So it will cancel out each other. That's why this displacement not going to count. The real displacement the body has traveled once it has gone from point A to point B. So this is H only, the relative displacement the body has traveled. So this point is important. How much relative distance the body has traveled? Only H. So that's why I have keeping the value of H as minus 25 because with respect to origin it is downward direction. That's why minus H. Fine. And U we have taken with plus sign. This is plus UT plus half G is equal to G is always downward direction. That's why minus G into T square. Now, if we have solved, we will get the two time interval T is equal to 5 seconds and T is equal to minus 1 second. There's a no meaning of T is equal to minus 1 second. We can say it will take T is 5 seconds to reach at the ground. So I thought you got the calculation basically how to calculate it. Now, graph I already told you the area, slopes, and slope will be, of course, this is the rising point, rising slope, constant slope. This is the rising, this is constant, and this is falling slope. Now the 1D you have seen XT graph, XT graph two type. Fine. Here we can say this is beggar's hand. Beggar. Once the beggar hand is there, so here we can say it will always going to fill with money. So it will increase only. And this is the reverse, so it will decrease. Maybe my students getting this point. This will rising and this will be increasing. We can say this is beggar's hand is increasing. And once we flip, everything will fall down, means decreasing. That is retarding. So you can learn by this way. Now, this type of slope you have seen constant line, rising line, and falling line. Here we can see once the acceleration displacement is supposed to calculate, and if it will come down, so there's a negative area, this is positive area, this is positive area. So overall displacement, we have to keep the value with sign, and distance we have to add only without sign. Now acceleration versus time. Here you can see acceleration versus time. Area below will going to give as negative. So it will going to give us change of velocity. The AT graph, I told you this is going to give me change of velocity. Now Vx graph, always remember Vx graph, the basic equation, like we can write V is equal to U tan theta plus. Now we can also calculate, like as we know acceleration is equal to V dV over dx. So V dV over dx, the slope will directly get by Vx graph. And once we have calculated V at that particular point, we can calculate acceleration by using Vx graph. Fine, so Vx graph is going to give me acceleration directly. Now, these are the questions that is based on it. Uh, so let's quickly see. Now here, this graph is AT graph. Now AT graph, a straight line shown at what time particle acquired the initial velocity 12, 5, 8, 16. Now here we can say the acceleration time graph they have given already. So for this graph, we can say once we have a stretch, so the area under the curve will going to give me V minus U. So V minus U, clear? So here we can say which particular option at what time the particle acquires the initial velocity. Initial velocity means v should be equal to u. So v is equal to u, the area once we have calculated. So here we can say the upper area and lower area are equal to each other. So basically the area if you are talking about, so both area will be, let's say it will give me v minus u, that is the area, correct? If area will 0, only then v is equal to u. And when the area will be 0, once we have extend this line up to the sum point in such a way, let's say what is the upper area? Half base into height. So this area must be equal to the lower area. So lower area, it will going to be half base into height. Now height would be once again 10. Height would be 10. So here we can say this coordinate will be 8 only. If this coordinate 8 only, then the effective area will be 0. Means total area means a minus 8 will be 0. And once a minus a, it will be 0. So we can say v is equal to u. V is equal to u means final velocity will be equal to initial velocity. This is what the situation is. So what time it will going to get once t is equal to 8. So this is one of the good question that will give additional thinking. The total area is change of velocity. Total area will going to be 0 only then v is equal to u. So this is one of the finest question we can say, which you can get. Now here, acceleration versus time graph, they have acceleration velocity graph they have given, and the corresponding to velocity versus time graph they have asked. So once again, this is a good question. You have to discover acceleration versus time graph. So here you can see now, since the given equation has a type y is equal to mx plus c, fine. So here c is positive and slope is negative because it is falling line. That's why it will be v is equal to minus mx plus c. So this is what it is written, y is equal to mx plus c, m is minus, and c is a naught. So a we can write as dv over dt because this is what we are looking for. So once you differentiate dv over dt, so you can get like a is dv by dt. This is the relation that we got. Now we will take the v to the v side. So I've taken this whole term to the v side and dt over dt side. And once we integrate, so dear, this is a new integration for you. Always remember integration of 1 by x dx is equal to ln x. So this is a new integration. Always remember, like if constant is there, power 1, always it will be ln x. So here this integration will going to give you ln x. And we can say ln x, that is the right hand side, it will going to give you t. And once we arrange the term, we can get v is equal to a naught upon m 1 minus e to the power minus mt. So here e to the power minus mt, this line is important. E to the power mt, e to the power x. We can say this is y is equal to e to the power x, e to the power x line. And this is y is equal to e to the power minus x line. Here, now there is a minus sign. Always remember if minus sign is there, so graph will be taken a 180-degree flip. So this graph, if we taken a flip, so it will become like this mirror image, and here you can say like this. Since one minus, so so we can say the graph is apparently, this is the nature of the graph should be there. So among all, whether the most suitable graph is option D. So this question is a bit tough because here first integration and the bit graph knowledge should be there. And we have discovered two integration, 1 by x dx is equal to ln x, and the next function is e to the power x, the graphical form, how to represent graphically. So these two it is needed to get the answer correct. Now next important graph. Now this is just like a homework. You can attend these two questions, and we will surely discuss the solution in the upcoming video. Till then, take care. Have a nice time.